Distance, rate, and time problems are another opportunity for us to apply our skills with solving rational equations. We often want to begin by reading the information we have and organizing it into a table that shows the relationship rate times time equals distance. So we have Bev, who likes to canoe, is taking a 5-hour trip in a stream that has a current. She leaves her dock and travels upstream for 2 miles and then returns to her dock. The stream has a current rate of 1 mile per hour. What is her canoeing speed in still water? So what we realize is that her speed is going to be a combination of her rate of canoeing and the current in the water. Rereading the question then, we realize that what they want to know is still water, so the variable of interest is this rate right here. This is our unknown. Her first activity then is traveling upstream, and her rate going upstream would be her canoeing rate plus the current of 1 mile per hour. Going downstream, she has her rate, and her current at this case is actually what's going to carry her going faster, and we revisit this thought and say, wait a minute, upstream the current is actually slowing us down. This thinking about current and its relationship to the effect on the still water rate is what allows us to clarify what the rate is of the activity. This inference in many word problems expects us to understand that going downstream adds the current rate and going upstream is a drag or subtracts the current rate. With that detail clarified, we now notice that she's been canoeing for 5 hours, so that would be her time, but it's spent in combination of going up and down, so I'm not ready to fill that chart in yet. We also notice that the upstream is 2 miles, so the distance makes sense to me to be 2 miles, and if she returns to her dock, then she would cover those 2 miles again. Now, how to go forward then might be made clear. We realize that the time is given as a total, and so I need to revisit this formula and think about time in terms of distance being divided by rate. And the total 5 hours then is going to be a combination of the time spent going upstream the distance of 2 at a rate and coming back downstream at a different rate. This experience of realizing that the time in this case was a total time arrived at by combining these two that were then seen in ratio of distance divided by their particular rate for that activity. Recognizing this then as a rational equation, we're reminded that in order to add, we need to have a common denominator. Multiplying by the equivalent of the number 1 in the first ratio, and similarly in the second ratio, we create a common denominator, and we will now go forward with simplifying the numerator so we can use our means extremes principle. Examining the steps will lead us to noticing that we do have, in fact, a quadratic equation to now solve. Applying the quadratic formula and then estimating, we arrive at 2 possible values for r. Now, common experience would tell us that in still water it doesn't make sense to have a negative rate, so our 1.5 will be the solution that we believe that Bev can canoe at a rate of approximately 1.5 miles per hour in still water.